The vacuum system has the same exact goals as what we just talked about with fingers, and that is to singulate and then to get that good spacing through consistent release. So let's go ahead and look at a picture here that's going to show you what most of you guys that have back planters are probably running. And that's the top half of this slide is the standard cell disc. Now it has a inherent flaw in that the cell doesn't like varying seed sizes. So there's a number of different seed sizes I got out of different bags and put on this cell disc, and you can tell there's a large flat there that's got his edge down in. The next seed is a small round, and those two different seeds are going to react differently to the cell. They're going to require different vacuums, and they're going to be more difficult to plant. The cell disc tends to do pretty well with a nice medium round seed, a consistent size. But as you start to go to flat seed, which we've heard about this morning, why you're going to want to plant flats for emergence, or you start to go to smaller seed, larger seed, the cell disc tends to struggle. It's also difficult to set your vacuum because you're trying to hit a knife's edge, trying to hit a narrow band of vacuum where you don't have too much where you're doubling, but you've got just the right amount so that extra seed falls off, but you don't lose two. You don't want to lose both seeds. You've got to keep your singulation up, but it's a real challenge. The eSet is different. And the reason is we've gone to a flat surface. We get away from the pocket altogether. The flat surface doesn't care what seed's sitting on it. It can seal the vacuum equally as well. So that allows us to then run higher vacuum. We run 15 to 18 inches, and it's not terribly sensitive. You can run real close to 18 and you'll do just fine. And the reason for that is because of the singulator. So instead of relying on vacuum to singulate seed, we just run enough. Run plenty of vacuum, get a good hold of the seed, and bring doubles out of the seed pool. And the reason you want to bring doubles out is because if you're trying to load just one seed out of the seed pool, chances are there's many times you're going to get skips. So load every hole. Bring as many seeds as you can and let the singulator do the job. So I'll show you what that looks like in the housing here. It's already built in. There's a place in your housing for the singulator. And it's spring loaded. There's no adjustment required, which is a great thing. It adjusts itself. The springs force it to stay home, stays on the disc where the setting is correct, and each lobe gets progressively more aggressive. So towards the bottom of this picture is lobe 1. It may take that double and just bump him a little bit. And by the end, the last lobe there, lobe 5, is covering nearly half the hole, and it's getting quite aggressive. By that point, most of the doubles are gone. You rock them back and forth till you get one seed to seal over the vacuum and the extra seed falls off. So the singulator really is the key to the system. It's easier to run too because again you're not looking for that perfect vacuum. You're getting right in the ballpark, you're running enough, and you're letting the singulator do the job. So we'll run the belt stand and show you guys what some of the singulation results look like with 2020. We'll flip over here and let you watch. And I'll just show you that this third row is the eSet system, and the far side is the cell disc. So just watch for the guys that can see the belt. Otherwise, we'll show you what it looks like up here. Let's just go watch row 4 to start with, which is the cell disc. Yeah, it should be roughly 8 inches. Running around 97%. You see a double, some misplaced seeds come across the bottom. Continue to watch here, running 98, say, 97.9. Right now our skips and mobiles are pretty balanced, about 1% of each. It'll be a little bit tough to adjust your vacuum to improve it much more, which way you're going to go because we're relatively balanced. Continue to watch and see what we see come across the belt. There's a skip and a double, so you've got both coming through the meter. Let's go ahead and flip over and watch the eSet system. See, we'll let it settle in. Run about 99.4. Run 100% seed placement. So for a seed like that, that's really quite good. Singulation, 99.7. Let's watch here for a second, see if we can get it go to 100. There it is, 100%. That's about a 300 seed average. So over the last 100 seeds, 300 seeds, it's going to run 100% singulation. Just watch and wait and see where the next error comes along. Still running real good. You can't ask for any more than that, obviously. Back to row 4. This is cell system, 95.5, 96%. So you guys can see the difference right there. So that's half the battle. Once you've got the seed singulated, Now we've got to get it to the ground. Got to get it through the seed tube. So it's the same thing we were looking at here with the belts, and that is, if we look back here, the eSet disc again has a key difference. It's thicker. It's got a raised surface. When the cell disc was designed, the housing for it was made such that the cell could let the seed come out and the seed rolls out of a cell disc. It doesn't fall straight down. So they needed to offset that disc so that it would roll to the center line. Once you go to a flat surface, it falls straight down. But guys have been frustrated with their cell discs. They've started to see the singulation problems in the field, struggle to get their vacuum set like they wanted it, and so they've gone and looked for a different solution. That was the sweet corn disc. The last several years, that's become more and more popular. But what we've seen is that it looks real good on a test stand, but you take it to the field and you don't get the results you want. And the reason for that is that the seed is hitting in the right side of the seed tube. You can see the mark right there. So the performance that you're looking for gets messed up in the seed tube. Why is that? Again, it comes back to the way the housing was designed, as I was explaining. When you design it for a cell disc, you plan for it to roll to the center line. But on a flat surface, the seed's going to fall straight down, and where's it going to hit? I removed the black cover that Derek's got right here so you could see, but that's where the seed hits right up inside here. So you can see then why the eSet is going to solve it. It makes logical sense that when you offset the disc, you raise the surface over and put it on the center line, you're going to get the results you want. So it's a combination of things between the singulator doing the job of getting down to a single seed and then offsetting the disc to put it on the center line and get it down safely through the tube. That's what causes it to be a successful system. So let's show you a little bit of high-speed video. This video here is for guys that are running 1.6 bushel boxes, what we call standard housing, standard meters. This is what you're going to have with the sweet corn style system. Pretty much any of the different kinds that are out there are going to run them almost exactly the same way. The seed's going to be released in the top right corner, same as the picture I showed you, where the seed's going to fall down and hit the black cover. It's on the right hand side of the tube. Watch the seed bounce across. So it bounces just above the sensor usually. So watch this seed. Bounces to the left, comes down the center line. Some bounce a lot, some don't barely bounce at all. And that difference is what causes the timing between the seeds to be messed up. So you watch, you see seed tumbling, taking more time to get out of the seed tube than the seed behind it, which is going straight through. So then if you are on a system that is what we call Pro Series, it has the mini hoppers. Every single year the manufacturer's been making slight tweaks and trying to catch up to the performance of eSet. They've made some small improvements, but I think you'll see with our live video here that there's still ways to go. It's not on the center line where it needs to be. Okay, watch up here again. Let's watch and see where the seeds enter in the seed tube. Again, you're seeing it to the right side. It's not in the center where it should be, and usually you'll see the seed bounce just an inch or two above the cord that's coming across the tube there. If you guys can watch, you'll see some, again, don't barely bounce. Some bounce back and forth 3 times. You see they're tumbling as well. It's not the consistent ride down the seed tube that you're going to need to get the results in the field. So Derek's going to set up, and he's going to show you the eSet system. Just move down 1 more meter there on this stand. We'll let him get his camera set. And while he's doing that, I'll show you one key thing to remember with any vac meters, that static electricity is a little thing that can quickly hurt your spacing. So we have eFlow, which is a combination of talc and graphite, 80% talc, 20% graphite. So the talc is good in that it cuts the static. Static causes the seed to hold on any plastic disc for too long, and it causes the timing again to be messed up. You want it to be consistent, just like a watch. Where eFlow gives you some lubrication as well for some of the elbows in these CCS systems. There's times the poncho treated seed needs that extra lubrication. It's something that Dad uses every single fill of our 1790. So don't think that you can do the big things and forget the small details. The talc is definitely a detail, but it's one that's important because it's going to mess up your spacing if you don't have it. So let's watch the high-speed video. Derek's got it set up. We'll let him run here, and we'll take a look at it. Okay, that seed right there is where you want him to be. The center line is just about where that seed entered the meter, right there. Just entered the tube coming from the meter down the center line. Is every seed perfect? No, but I think the results in the field are exactly what we're looking for. And you can see it on this belt too. If you look at the consistency of the spacing, if you spread your fingers to the average spacing, you'll see that it's very, very consistent. It's picture perfect. And definitely not going to see any economic loss, any yield loss on the spacing that we see. So eSet has arrived in the sense that we have the singulation, we have the spacing, those two combined work together for the results you see in the field. And it's really been tremendous for us.